Hello everyone, welcome to our presentation. Today we're going to explore the fascinating world of electricity and circuits. The title of our session is Electricity and Circuits, and there's also a subtitle that complements our main topic. Over the next few slides, we'll cover the basics of how electricity works, understand simple circuits, and see how they impact our daily lives. I'm excited to take you through this journey. Let's get started. Let's take a quick look at the contents of today's presentation. We'll start with an introduction to electricity, which is the foundation of everything we'll discuss. Then, we'll explore electrical energy and see how it powers our daily lives. Moving forward, we'll look inside a torch to understand how it works, including key components like the electric cell and electric bulb. We'll also examine the components of an electric bulb, which help it produce light efficiently. After that, we'll delve into electric circuits, what they are, how they function, and the different types. We won't forget about switches and solar cells, which are crucial in controlling and harnessing electrical energy. Lastly, we'll consider the types of substances involved in electrical conduction. All these points are interconnected, helping us understand how electricity impacts everything around us. Let's begin with an introduction to electricity. Electricity is a fundamental form of energy that powers much of our daily lives. It's what makes our lights turn on, our devices work, and many of the technologies we rely on possible. Understanding electricity is crucial because it underpins so many aspects of modern society. At its core, electricity involves the movement of tiny charged particles called electrons through a conductor, like copper wire. This flow creates electrical energy that we can harness for various uses. By grasping the basics of electricity, we can better appreciate how it's generated, transmitted, and used safely and efficiently. Throughout this presentation, we'll explore these concepts in more detail, connecting the dots to see the bigger picture of how electricity shapes our world. Let's take a closer look at the inside view of a torch. When we examine the interior, we see the key components that make the torch work. At the core, there's usually a flame or a light source, which is protected and supported by various materials. These materials are designed to withstand high temperatures and ensure safety. The combustion chamber, for example, is where the fuel mixes with air to produce the flame, and understanding how this works is crucial for improving torch design. Additionally, the internal structure often includes insulation to contain heat and prevent damage to other parts. By understanding these internal mechanisms, we can appreciate not only the engineering behind a torch, but also how it effectively provides illumination or heat in different applications. Connecting this to our overall theme, the inside view highlights the importance of thoughtful design and engineering precision. It reminds us that even something as seemingly simple as a torch involves complex, carefully engineered internal components that make it functional and safe to use. Let's take a closer look at the electric bulb. The electric bulb is a small, simple device that provides light. It works by passing electricity through a tiny wire called a filament. When the electricity flows through this filament, it heats up and begins to glow, producing light. This process is what makes the bulb so effective as a light source. The filament's ability to glow without burning out quickly is what makes the electric bulb both practical and reliable. Connecting this to our overall theme, the electric bulb revolutionized how we light our homes and workplaces, making life brighter and more productive. Now, let's take a closer look at one of the most essential components of an electric bulb, the filament. This is a very thin wire inside the bulb that plays a crucial role. When electricity flows through it, the filament heats up to a very high temperature and begins to glow, producing light. The filament's ability to glow without burning out quickly is what makes incandescent bulbs effective. Its material is usually tungsten because of its high melting point and durability. Understanding how the filament works helps us appreciate the science behind the light we use every day and how electrical energy is converted into visible light. This component, though small, is truly the heart of the bulb's function. Let's take a closer look at what we mean by terminal in the context of electrical circuits. A terminal is essentially a point where wires are connected to an electric cell, a bulb, or any other electrical appliance. Think of it as the connection point that allows electricity to flow in or out of the device. This is a crucial concept because, Without proper terminals, the electrical circuit wouldn't be complete and the device wouldn't function. When you're setting up or troubleshooting electrical systems, identifying terminals helps you understand how the current moves through the circuit. So remember, terminals are the vital connection points that keep the flow of electricity going, making sure your devices work smoothly and safely. Let's talk about electrical energy. This type of energy is caused by moving electric charges, which we call electrons. When these electrons move, they generate electrical energy. Now, an important point to remember is that the faster these charges move, the more electrical energy they carry. So, the speed of electron movement directly influences how much electrical energy is produced. This concept ties into the larger idea of how energy transfers and transforms, showing us how vital the movement of tiny particles like electrons is in powering everything around us. Now, let's talk about the electric cell. An electric cell is a device that plays a crucial role in converting chemical energy into electrical energy. Essentially, it takes the energy stored in chemical substances and transforms it into the electrical power we can use to run our devices. This process is fundamental to how batteries work, powering everything from our smartphones to electric vehicles. Understanding this conversion helps us see how chemical reactions can be harnessed to generate usable electrical energy. It's a key component in the larger picture of energy sources and their applications. Let's talk about an electric circuit. An electric circuit is essentially a path that allows electricity to flow from one point to another. Think of it like a loop or a circle that keeps the current moving. Now, a simple electric circuit usually includes a few basic parts. First, there's a cell, which provides the electrical energy. Then, we have a torch bulb, which lights up when electricity flows through it. And finally, there are two pieces of wire, often called connecting wires, that link everything together. These wires make sure the current can travel smoothly between the cell and the bulb. Understanding this simple circuit helps us see how everyday devices work, and it's the foundation for more complex electrical systems. So, the key idea here is that a circuit forms a continuous path that enables electricity to do useful work, like lighting a bulb or powering a device. Let's take a closer look at the two main types of circuits. First, we have the open circuit. An open circuit is essentially a path that is not closed or continuous. This means that electric current cannot flow through it because there's a break somewhere in the path. Think of it like a switch that's turned off or a broken wire. The symbol for an open circuit is shown as an O, which helps us quickly identify it in diagrams. Now moving on to the closed circuit. This is a complete and unbroken path, which allows electric current to flow freely. When everything is connected properly, the circuit is closed, and electricity can do its job, powering devices, lighting bulbs, or running motors. The symbol for a closed circuit looks like a continuous line, shown as a dash or a straight line. Understanding these two types of circuits is fundamental because they form the basis of how electrical systems are designed and operated. Whether a circuit is open or closed directly impacts whether devices will work or not. So, grasping this distinction helps us see the bigger picture of how electricity moves through different systems. Let's talk about what it means for a switch to be open. When we say the switch is open, it means no current is flowing from the cell. Essentially, the circuit is incomplete or broken. Think of it like a door that's slightly ajar. It prevents electricity from passing through. This is an important concept because an open switch effectively stops the flow of current, which can be useful when we want to control or interrupt a circuit. Remember, the state of the switch, whether open or closed, directly impacts how the circuit functions. So, understanding open switches helps us grasp how to control electrical flow in various devices and systems. Let's talk about what it means when a switch is closed. When we say a switch is closed, it means that current is able to flow from the cell through the circuit. Essentially, the circuit becomes complete or closed, allowing electricity to move freely. This is a key concept because, in electrical circuits, closing the switch is like opening a door for current. It enables the circuit to function. So, whenever you hear about a switch being closed, think of it as turning the circuit on and letting the current do its job. This idea ties into the overall theme of how circuits operate and how we control the flow of electricity. Let's talk about solar cells. These are fascinating because they directly convert the energy of light into electrical energy. Essentially, when sunlight hits the solar cell, it excites the electrons, creating an electrical current. This process is what makes solar cells so efficient for harnessing renewable energy from the sun. They're a key component in sustainable energy solutions, tying into our broader theme of clean and renewable power sources. The most important thing to remember is that solar cells transform sunlight directly into electricity without any moving parts, making them reliable and low maintenance. This direct conversion is what makes solar technology so promising for the future of energy. Let's talk about insulators, which are a type of substances. Insulators are materials that do not allow electricity to pass through them easily. This is a key point because it helps us understand how we can control and protect ourselves from unwanted electric shocks. Now, one of their main characteristics is that they resist the free flow of electrons, meaning electrons don't move freely through these materials. This quality makes insulators very useful in many electrical applications. For example, common insulators include plastic and wood. These materials are often used to coat wires or to make handles and casing for electrical devices, ensuring safety and proper functioning. So, understanding insulators is essential in recognizing how electrical systems are designed to be safe and efficient. Now, let's talk about conductors. Conductors are substances that allow electricity to pass through them easily. They are essential in electrical circuits because they enable the flow of electric current from one point to another. One of the key characteristics of conductors is that they allow free flow of electrons, which is what makes electrical conduction possible. Examples of good conductors include iron rods, steel, and other metals. Understanding conductors helps us grasp how electrical devices work and how we can efficiently transfer electricity in various applications.